Hello, and welcome to my poster presentation. My name is Shoman. I'm a PhD student here at the University of Missouri, Columbia, and today I'll be presenting the project that I worked on along with my supervisor, Dr. Yao Adugiamfi. Our project is titled Visualizing Transit System Performance Impacted by COVID-19 Virus, a case study of St. Louis, Missouri. Before I start, let me zoom in to our developed dashboard where you can scan it with your phone and on this barcode here, and you can view everything that I'll be discussing today. My poster is outlined as follows. I'll first talk about introduction and goals and motivation for this topic, then our data source, methodology, applications, results, and then finish with a conclusion. Let me zoom into the introduction and talk briefly about why we chose this topic. The COVID-19 outbreak is causing serious implications on computer behavior and transportation systems around the world that are worth understanding. Thus, we developed two main goals. One is developing an interactive analytics platform developed using a cloud service such as Microsoft Azure, and automating the whole process from collecting data, cleaning it, pre-processing, calculating performance measures, and then visualizing it. Our data sources are real-time feed of the bus network, which means GPS locations, and GTFS transit data, which refers to the static scheduled bus data. The data was mapped using bus feed points to the respective stops. So we made sure that within a radius of 20 feet or 0.01 miles buffer was used to return the nearest point to make sure that this is where the bus stopped. That was used to calculate delays, trip duration, cycle time, and headways at stops. Data was collected or pre-COVID from 13th of December to 8th of January, 2020, and during COVID from 20th of April to 13th of May. Applications of our data shows that we can use it to simply select certain routes, study particular routes on the bar graph, look at certain times on our area map, select certain directions from our pie charts. The results show that the average delay was actually improved during COVID. However, on certain routes, the delays was worse because of certain routes. Upon further investigation, we found that they were stopped, and though the demand on other routes was higher, and this is why the demand was worse. However, direction, we can see that the direction was, the duration of trips on the city center direction was actually worse. And this resulted in them reducing. And then the cycle time, however, increased simply because more trips were performed. The headways was higher during at all directions, which means that buses were at a less frequent service, given the change in schedule. Conclusion of results show that the routes and trips were reduced by 30%. However, average delay was reduced by 30%. Headways and durations were increased by 14% and 1% respectively. We believe that this interactive analytics dashboard will help in making more data-driven decisions by transportation authorities and academics. We will continue to navigate these challenging times by studying more and more trends and updating our dashboard. Thank you.